In this lecture, we will look at the advantages of using the database management system approach. We look at the advantages of using the DBMS approach. The advantages of using DBMS are: it helps in controlling redundant information, restricts an unauthorized access to the database, provides persistent storage for program object, provides storage structures and efficient search methods, also provides techniques for efficient query processing, provides backup and recovery, provides multiple user interfaces, helps in representing complex relationships, enforcing different types of integrity constraints, and permitting inferencing and actions using rules. Let's have a look at the first advantage, that is controlling redundant information. Here we consider the university database example. We have two users, the grade reporting office and the accounting office. Both the offices maintain information about students. Each office maintains their own files. The accounting office keeps data on registration and related billing information along with the personal details of the student, whereas the grade reporting office keeps track of student courses and grades along with their registration details and personal details of the students. Since personal information about students is maintained in both the offices, there is redundancy of data. So, common information stored across both the offices causes redundancy of data. Now, this redundancy of data will lead to several problems. Entering data of a new students will be done multiple times, once for each file where the student data is recorded. So, if there is a new entry in the university or the college, information of the students will be stored in both the offices. So, basically there is duplication of information. So, the name, roll number, branch and the address of the student will be stored in the grade reporting office, and also the same information will be duplicated in the accounting office. The next problem is, since there is so much of duplication, storage space is wasted because the same information is repeated at different location, and this can be a serious problem for large databases. Finally, the data can be inconsistent. Now, what does it mean? Files that represent the same data may become inconsistent. This may happen because an update is applied to some of the files, but not to others. Even if an update such as adding a new student is applied to all the appropriate files, the data concerning the student may still be inconsistent because the update are applied independently by each user group. Now, in this case, John is a student whose phone number is given over here. This phone number reflects in the grade reporting office, as well as it also reflects in the accounting office. Assuming that John has a new phone number now, this phone number has to be reflected in the grade reporting office and the accounting office. So, John all by himself gives this information to both the offices. The grade reporting office updates his phone number, but the accounting office somehow misses to update this information. Because of this, the phone number of John becomes inconsistent. Certain terms that you require to know, like data normalization. Ideally, we should have a database design that stores each logical data item. such as a student's name or date of birth in only one place in the database and not at various multiple locations. This is known as data normalization. It ensures consistency and also saves storage space. As you can see in the figure, the student's personal details must be stored only at one location or only in one table, and the required information may be shared with the other officers. Now, in this case, we have student John, whose information has to be reflected in the grade reporting office as well in the accounting office. So, here we can see John has got A plus with a percentage of 92, and in the accounting office he is in the 5th semester and has also paid the hostel fees. Now, the grade reporting office, along with the grade of the student and the percentage of the student, also adds a new attribute to this table called as a roll number. Now, this roll number refers to the student's personal details table. So, if you want to find out this A plus grade belongs to which student, we make use of this roll number. We refer to the student's personal details table. We get to know that the name of the student with roll number 18001 is John. The same thing happens in the accounting office file. Next, restricting unauthorized access. A DBMS should provide security and authorization subsystem, which the DBA uses to create accounts and to specify account restrictions. The in charge of grade reporting office will not have any access to the accounting office information, and similarly the accounting office will not have any access to the grade reporting office. It all depends upon the privileges given to the user by the administrator. But in the hierarchy, at the top position, assuming it is the principal or the director or the head of the institute, may be given permission to view information from both the offices, but not to edit them. The next advantage, providing persistent storage for program objects. The main reason for object-oriented database systems is this: databases can be used to provide persistent storage for program objects and data structures. The value of program variables or objects are discarded once a program terminates, unless the programmer explicitly stores them in permanent files, which often involves converting these complex structures into a format suitable for file storage. When the need arises to read this data once more, the programmer must convert from the file format to the program variable or object structure. Such an object is said to be persistent, since it survives the termination of program execution and can be later be directly retrieved by a program. Traditional database systems often suffer from so-called impedance mismatch problem, since the data structures provided by the DBMS were incompatible with the programming language data structures. The next advantage, providing storage structures and search techniques for efficient query processing. The database systems must provide capabilities for efficiently executing queries and updates, because the database is typically stored on disk. the DBMS must provide specialized data structures and search techniques to speed up disk search for the desired records. Auxiliary files called as indexes are used for this purpose. Indexes are typically based on a tree data structure or a hash data structure that are suitably modified for disk search. In order to process the database records needed by a particular query, those records must be copied from disk to the main memory. In the example, the table is ordered on ID. Assuming that the user requires to query this table on L name, that is the last name, from time to time. So, what the user does is, he applies an index on the last name. The table B shows how the table will appear if indexing is done on the last name attribute, that is L name. It is the same data, but in a different sequence, basically sorted alphabetically. If the user has to search for Joe in table A, how the search will be performed? All the rows will have to be checked one by one. But in table B, it will come to index 3 directly because it is sorted in alphabetical order. So, it will come to J, okay, and keep moving downwards until it finds a different value. So, if this is the only value that it finds, then it will return Joe. And in the second record, if there is one more person, let us assume this is Felcy Joe, then that also will be a return. But in this case, it is Felcy Lewis. So, only this row will be returned. But in the first case, what will happen is, it will search for the first row, second row, third row. Okay, there is an entry over here. So, it will return this row and then go for the next record, the next record, the next record, and so on until and unless it reaches the end of the table. The next advantage, providing backup and recovery. The backup and recovery system of the database is responsible for recovery. For example, if a computer system fails in the middle of a complex operation or a transaction, the recovery subsystem is responsible for making sure that the database is restored to a state it was before the transaction started executing. So, basically what happens over here is, when you initiate a transaction and because of some unknown reasons your transaction fails, let us assume that you are doing a back transaction, transferring some amount from account A to account B, and for some reason your transaction fails, then whatever process or whatever events had taken place, all those events have to be undone. So, your database moves back to a consistent state the way it was before the transaction failed. The next advantage, providing multiple user interface. This includes query language for casual users, programming language interfaces for application programmers, forms and command codes for parametric users, menu driven interfaces and natural language interfaces for standalone users. Now, both the form style interfaces and menu driven interfaces are commonly known as GUIs or graphical user interfaces. So, for each user there is a different interface that it provides. So, based upon which category you belong to, you make use of your appropriate interface. The next advantage, representing complex relationships. A DBMS must provide or must have the capability to represent a variety of complex relationships among the data, to define new relationships as they arise, and to retrieve and update related data easily and efficiently. Now, here we have an example or a database that stores information about students and their courses. The first table gives information about the student. It has attributes student name, student number, or we call it as the student roll number, the class and the major. There is another table called as grade report, which stores information about the roll number of the student or student number, the section identifier or the section they have opted for, and the grade they achieved. Similarly, one more table which gives you detailed information about the sections, like section identifier. For example, over here section identifier 85, the course number is math, the semester was fall, and in the year 2007 was taken by an instructor named King. We have another table over here called as course, which gives the name of the course number, the credit hours, and to which department the course belongs to. Now, basically we have to see if there is any relationship between these four tables. Okay. The record for Brown, the student named Brown, in the student file is related to 4 records in the grade report. How is it? Okay. Student Brown, roll number is 8. Is this information mentioned in the grade report? Yes. We have the roll number 8 appearing at 4 different places, giving his detailed information about which section he has opted for and what are the grade he has achieved. So, what does this 85, 92, 102, 135 mean? What are these courses? So, 85, 92, 102 and 135. The information about this section is given in the section table along with the course number and the instructor, along with semester details and the year. So, we know that student Brown had opted 85, where 85 means math 2410. So, what is this math 2410? This is some kind of a course number. What is the name of course? So, this information we will get in the course table. So, in the course table, math 2410 is discrete mathematics and it is offered by the mathematics department. So, such type of complex relationships can be shown using a database. Next, enforcing integrity constraints. A DBMS should provide capabilities for defining and enforcing this constraint. The simplest type of integrity constraint involves specifying a data type for each data item. So, basically over here a catalog of a database is shown. In the catalog, it shows that there are these relations or there are these tables and the number of columns for this table is 4, number of columns for this table is 4, number of columns for section is 5, number of columns for grade report is 3 and the number of columns for prerequisite is 2. The information about each column is given in the columns table in the database catalog. So, when we refer to the first relation or the first table, that is student table, we have 4 columns or 4 attributes. Those 4 attributes are name, student number, class and the major. The data type of name is character, which is not more than 30 characters. So, this is a constraint on the first attribute. Another constraint is on the student number, which says the data type is 4 and cannot be more than 4 characters. Another constraint on class, where it should be integer, and so on. So, this type of integrity constraints can be enforced. A more complex type of constraint that frequently occurs involves specifying that a record is one file must be related to records in another file. For example, in figure we can specify that every section, we have already seen this example, that every section record must be related to the course record. Every section record must be related to the course record. This type of integrity constraint is called as a referential integrity constraint. We will look at this in detail in the further units. So, an explanation to the previous slide. So, what does the previous slide say is, it says that every section record must be related to the course record. Every section record must be related to the course record. So, every section record must belong to the course record. So, in this case we see 85,112 belongs to discrete mathematics, right, because the course number is MAT 2410 and here also the course number is MAT 2410. Similarly, CS 1310 belongs to the computer science department, where the name of the course is Introduction to Computer Science. CS 3380 belongs, the course name is database and it belongs to computer science. So, basically all the records in the section are related to all the records in the course table, which is called as a referential integrity. The next constraint specifies uniqueness on a data item value, such as every course record must have a unique value for a course number. This is known as a key or a unique constraint. So, here we have a course name called as Introduction to Computer Science, where the course number is CS 1310. We have data structures where the course number is CS 3320. We have discrete mathematics where the course code is MAT 2410. So, basically if you look at this course numbers, they are unique, which is called as a key, which will help you to uniquely identify a record in a table. We can have one more course with the same name, Introduction to Computer Science, but the course number for that particular subject will differ, it cannot be the same. Only in such cases then this particular attribute will be called as a key. Finally, moving to the last advantages, permitting inferencing and actions using rules. Some database systems provide capabilities for defining deduction rules for inferencing new information from the stored database facts. Such type of system are often called as deductive database systems. For example, there may be complex rules in the mini world application for determining when a student is on probation. This can be specified declaratively as rules, which when compiled and maintained by the DBMS can determine all students on probation. What do you understand by triggers? In today's relational database system, it is possible to associate triggers with tables. So basically, a trigger is a form of a rule activated by updates to the table, which results in performing some additional operation to some other tables, like sending messages and so on. And finally, moving to the last topic, that is stored procedures. More involved procedures to enforce rules are popularly called as stored procedures. They become a part of the overall database definition and are invoked appropriately when certain conditions are met. So, these are called as stored procedures. So, we have seen the various advantages of using the DBMS approach. Thank you.